Hi all, how are all you doing? So in this lecture we will be studying something very interesting, that is how to analyze recursive function. So over here a recursive function is given in which it's calling itself with half the parameter of the current function. So we need to analyze that how time complexity of these kind of functions can be calculated. So uh, while dealing with recursive function, we can write a recurrence function for the function given. So the recurrence function of this shall be t of n is equal to 2t of n by 2 plus 1. So the explanation for this recursive function, recurrence function, is that the function a in this function, whenever n is greater than equal to 1, so it would be calling the function a twice. So that's why we are having this constant with t, we are calling it twice, so that's why 2t. And this n by 2 is because in the function we are giving the half the parameter which was given for the current function, so that is why it's 2t n by 2, and 1 over here is used for returning the value. So that's why the recurrence function of this function is this. And t of there is one thing to note, that t of 1 is equal to 1, because when t of 1 or 0, so whenever n is equal to or greater than 1, or let it be 0 rather, so the time required would be 1, so one command would be run for that. So when we are having recurrence function, then we need to calculate tc from it. So for doing so, I'll again rewrite the recurrence function to tn 2t n by 2 plus 1. So this can be again written as 2. This I'll expand t n by 2, so it can be written as 2t n by 4 plus 1, and outside bracket is 1. So so this can be written as 4t n by 4 plus 2 plus 1. So I'll again expand this thing over here, so I'll write 4 into 2t n by 8 plus 1 plus 2 plus 1. So this can be written as 8t n by 8 plus 4 plus 2 plus 1. So if I do this for k steps, so this can be written as 2 raised to power k, because in the first step I was having 2, in the second step I was having 4, in the third step I was having 8. So the constant used is the power of 2 into I, where I is the step. So after k steps, this would be my recurrence function. So it's 2 n by 2 raised to power k plus 2 raised to power k minus 1 plus 2 raised to power k minus 2 plus dot 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 plus 4 plus 2 plus 1. So this thing over here can be written as 2 raised to power k minus 1. So this whole thing shall become 2 is for k, t n by 2k plus 2k minus 1. So we are knowing that at t1 we are having 1, so we want to make this thing equal to 1. So this thing will be equal to 1 when n by 2 raised to power k is equal to 1 when k is equal to log of n. So if I replace this value over here, so it shall become 2 raised to power log of n t1 plus 2 raised to power log of n minus 1. So it shall give me n 2n minus 1. So I know that when the time required is this for t of n, so I know what would be the time complexity. So the time complexity over here is O of 2n minus 1, and we know that we can ignore the constants used over here, so this thing can be written as O of n. So the function given to us over here has time complexity of O of n. So I hope that this example was clear to you. So there are more videos yet to come, so kindly stay tuned and keep on learning. Thank you.